Next up, the surface area of a 3D figure with plane faces is the sum of the areas of its faces. So you can kind of either collapse the figure into its net and then find the surface area or the area of the net, or you can just think about it either way. So you can either flatten it out or think about what it would look like flattened. So for example 2, we're finding the surface area of this square-based pyramid. So square-based meaning, and if you look closely in this diagram, you can see that all 4 of these sides on the base have those little notch marks that mean they're all 13.2 centimeters. So I'm going to figure out the area of the base first. So my base, when I'm finding the area of a square, I can just say that it's one side cube or one side squared, or multiply the length times the width or the length times the height, however you want to think about it. But either way, you're doing 13.2 times itself or squared. Either way, you're getting 174.24. Again, not rounding until the very end, so I'm leaving it with all 5 of those sigfigs. Next, I'm going to take one side of my pyramid. So I'm going to focus on one of these triangles. Again, it has the same base, so it has that 13.2 centimeter base. It also gives us the height, because if you remember, the area of a triangle is 1/2 times the base times the height. So it also gives us the height of 22.4 centimeters. So I'm going to say my sides, because I have 4 of them, 1 for each side of the pyramid. So I have 4 of this formula that I'm going to use for a side. So again, 1/2 times my base times my height. Multiplying that all together, I get 591.36. And then to finish this out, we'll take both of those and we'll add them together. And we'll get 765.6. So IB, we know, likes 3 significant figures. So I'm going to go ahead and round that up to 766. And we are in centimeters squared because we found the area. So while we probably all know what the formula is for the area of a triangle or for the area of a rectangle or square, curved surfaces are a little bit harder. So these are all given to you in the formula booklet as well. They are on pages 2 and 6. All right, so example 3, we're finding the surface area of all 3 of these diagrams to 1 decimal place, or to the 10th. So in letter A, the first thing you might notice is they tell you it has a hollow top and bottom. So what that means is we are not including the circle on the top or the circle on the bottom of this cylinder. We are only including the curved surface. And so our area of the curved surface from the formula booklet from the previous slide is 2 pi r h, or the radius and the height. So subbing in the values that we know, we're given the radius is 6 and the height is 15. So putting that into my calculator or putting it into Desmos, I get 565.486, etc. So rounding it to the nearest 10th, I'm getting 565.5 centimeters squared. Don't forget those units. Part B, we have a sphere. So the area of the surface area of a sphere is given to us again in the formula booklet or on the previous slide by 4 pi r squared. So just subbing in our radius of 8. And again, calculator or Desmos gives me 804.247, etc. So correct to the nearest 10th, I'm getting 804.2 centimeters squared. Finally, part C, note that it does not specifically say that it has a hollow top. So that means we are including this circle on the top. And if you recall, the area of a circle is just pi r squared. So looking first at the area of the slanted piece, again, from the formula booklet or from the previous slide, the formula is pi times the radius times the slanted length, which they use L to represent that. I'm also going to add in, again, the area of our circle on the top, so I don't forget it. Oops. And then sub in what I know. So I'm going to keep my pi's in there. My radius is 5. My slant length is 12 plus pi times my radius of 5 squared. We can do all of that in one swipe in our calculator, and we will get 267.035, etc. So correct to the nearest to the nearest tenth, 267.0 centimeters squared.